Today I'm going to explain what SOHCAHTOA means and how we can use it to help us find angles and sides in right angled triangles. So firstly, we need to look at labelling our triangle, and that's going to help us decide whether we want to use sine, cos or tan for our question. So we have three sides to label, which is the adjacent, the opposite and the hypotenuse. Remember that the hypotenuse is the longest side of the triangle. If you can't quite figure out which one is going to be the longest side, you can always remember that it's going to be opposite the right angle. So this one here will be H. Next up, we're going to look at the side which is opposite the angle which we know. In this scenario, we know this angle here. So the side that we're going to label is directly opposite, which is here. So this side is our opposite. Finally, we're going to label the side which is adjacent to the angle, which just means next to the angle that we know. So that's going to be this one here. Now that we've got our sides labelled, we can figure out which of sine, cos or tan we're going to use to help us find whatever we need to find. So let's take a look at what SOHCAHTOA actually means. We've got S, which stands for sine, C, which stands for cos, and T, which stands for tan. And these are the trigonometric functions which you have buttons for on your calculator. Now what about the O's, the H's and the A's? Well, these are the opposite, adjacent and hypotenuse that we talked about on the last slide when we labelled our triangle. So that's what the letters stand for, but how does this actually help us? If we just take the first part of SOHCAHTOA, the SO part, for example, this stands for sine of the angle, in this case we'll call it X, is equal to opposite over hypotenuse. And all the other parts follow exactly the same pattern. So when we get to the CA part, we're going to have cos of the angle is equal to adjacent over hypotenuse, because we've got the A and the H here. And then finally, this one is going to be tan of X is equal to opposite over adjacent, because we've got the O and the A. So they all follow this same pattern where we have sine, cos or tan is equal to one side over another side. And SOHCAHTOA just helps us to remember which way round those sides go. So next up, we need to look at how we decide which of these to use when we want to find an angle or a side, and secondly, how to actually use it. So let's do an example. So here we've got a triangle, and the first thing we always want to do is label our sides. So we're going to look for the hypotenuse, the opposite and the adjacent. So the hypotenuse is the longest side and it's always opposite the right angle, so that's going to be this one here. The opposite is the one that's opposite the angle we know, and this here is the angle we know. So this one is going to be our opposite, and the adjacent is the one that's next to the angle that we know. Now I'm just going to write out the phrase SOHCAHTOA as a reminder for whilst I'm doing the question. The next step I need to do is see what we actually have and what we know from the question, and also what we're finding out. In this scenario, we know the hypotenuse and we're finding the opposite. We're not using the adjacent anywhere in this question. So for this one, we need to look for the part that has O and H, and that's the first part of SOHCAHTOA, which is the SO part. Now if we write out the equation for this, it's going to be sine of the angle is equal to opposite over hypotenuse. Next up, we're going to substitute in the values that we know from our drawing. We know that the angle is 40 degrees, and we know that the opposite, we're just calling it X right now, and the hypotenuse is 8. The final step from here is we need to rearrange this so that it says X equals something. So I'm going to multiply both sides by 8. That's going to leave me with X equals 8 sine 40. And finally, I'm going to put that into my calculator to get 5.14 centimeters, and that's to 2 decimal places. Now let's have a look at how we would use SOHCAHTOA if we're finding an angle. So the first step again is always to label our sides. We want to label the hypotenuse, the opposite and the adjacent. This angle here is still the one we're looking at, even though we don't know it yet. The side that is opposite to the angle is going to be this one here, because if you drew an arrow straight out of the angle, you'll directly hit that side. This side here is going to be adjacent to the angle because it's the one that's next to it. And then this side here is the hypotenuse because it's the longest side and it's opposite the right angle. Again, I'm going to write SOHCAHTOA out just so I can use it as a visual. So again, now I need to look at what things I actually have in the question that I'm going to use. I'm going to be using the angle for sure, and I'm going to be using this side and this side because they're the ones that we know. So again, we're going to be looking at the SOH part of SOHCAHTOA. So if I write the equation out, I have sine of x is equal to opposite over hypotenuse. My next step again is to fill in the equation with the things that I know from the question. So I have sine of the angle is equal to the opposite, which is 5, over the hypotenuse, which is 9. Now I need to rearrange this to get it to say x equals. So this time we're going to have to do the inverse of sine to both sides. That means the opposite of sine. So what I'm going to be left with is x equals sine minus 1, which is a button on your calculator, of 5 over 9. And if we type that in, 33.75, and that's degrees. I hope this helps, and let me know in the comments what type of question you'd like to see next.